This is video 3 of 5, chapter 6, functions. In this video, we're going to talk about functions that return values. We're going to do some examples of functions and how you might use them. We will also introduce the notion of overloading, which simply means you can have multiple functions with the same name, but their parameters are different, and the compiler is able to distinguish one of the functions from the other by the way it is used. So let's go back to the first function I showed you, where we have a function in C math called square root, and we're able to use it. And we recall that when we use a function that returns a value, we must catch the value. So we typically will call it wherever an expression is required. The same is true if we use a function that we make ourselves. So now, if you want to return a value, the body of the function must contain a return statement, and the value that is returned is converted to the type that's indicated in the function header. Now, there are different ways to catch the return value. So when you call a function, you can take the value that's returned and assign it to a variable, or you can send it to an output stream or file. You can use it within an expression, or you can use it as an argument to another function call. Notice that when the return statement is executed, you have completed the execution of the function, so you go back to the calling site. If there is no return statement, such as in void functions, the function execution ends when you hit the closing block delimiter. And again, the return statement can specify any expression. So let's look at a function that returns a Boolean value. The thing we remember about Boolean values is they can be used wherever true or false the value of the function call can be used immediately wherever a true or false expression is permitted, such as in the condition of an if statement or a while statement. So here's the example of the function is valid, and the goal is to make sure that a value is within the range 0 to 100. The body of the function this is missing something. Okay, this is missing something. Let's just keep moving. Instead, let's go look at the function itself. Okay, here's the function. Here's the correct version of it. Okay, so we're checking that the function is within the range 0 to 100. And so the function has a max and a min, and it simply checks that I am greater than or equal to the min, less than or equal to the max. That means I'm within the range. If so, return true, otherwise return false. The use of the function is illustrated down here. I'm going to call it with num1, which is 14, within the range. Num2, 101, is outside of range, and num3 equals 0 is in the range. It's at the lower boundary. So when we call this, we expect that is valid is going to return true the first time, it's going to return false the second time, and true the third time. Okay? So we're just calling it twice, rather. Calling it twice. So let's run this and see what we get. So when we run it, we see that 14 is valid and 101 is outside the range. It's important to note that the function call itself delivers a true or false value, so I don't need to do anything for the if statement, because the if says whatever goes inside of the parens has to be true or false. The function, in fact, delivers a true or false value. Now let's take a look at how we can use a function that returns a value to read an input. Notice that the function readNum returns an integer, but it does not take an argument. So think about it for a moment. When you call this function, really the only way you get a number back is that one is returned to you. Let's look at the body. Function header, no semicolon. In the body, we must declare a local variable called v, and this variable belongs to this function. When the function terminates the value, the variable no longer exists. So we will prompt for an input, read the input, and return what we have. So in the calling function, we need a variable that we want to read a value for. We read a value by calling the function readNum. readNum is going to return whatever was read in, and that's how we accomplish it. Okay. Here's another version of an input function. This time we want to read a string, and the function requires that you give it the prompt. The prompt basically says how you ask for your input. So the body of the function says I need a variable called s that belongs to the function. I will issue the prompt that was passed. I will read using getLine an entire line of text, and I will return what I read. So here's the calling module. You declare a string, you read the string by calling read. You're able to put in your own prompt. Let's see if we have a version of that in here. May work. Let's try this. So here's a version of what we were talking about. Okay. Notice that in this program, we put the prototype up here. Having the prototype here means that the main knows about it, so it can make the call. The compiler can evaluate whether the call is valid. Then the body of it comes after the main. So let's run that and see what we have. We'll run that. Enter a phrase, good day. And we're going to enter a sentence, this is a good day. Okay? Alright. Alright, so it's fishy. Alright. Now let's talk about function overloading. Again, overloading simply means two functions can have the same name, but if they have different parameters, and the parameters, the difference in the parameter is twofold, is the number of parameters can be different, or the types of the parameters can be different. That is, the first parameter of one can be an int, the first parameter of another one, if it's a float, then that makes the functions different, because the first parameter of one is different from the first parameter of the second by type. And the compiler is able to determine which version of the function you talk about. Let's take a quick look. We have four functions called getDimensions. The first function has what characteristic? It has one argument, and that one argument is an int. So let's look at the calls down here. Which of the calls are possible candidates? Well, call 4, 3, and 2 cannot be because they have two arguments. So the only other choice is the first one. So let's take a look at the first one. The first one has one parameter, and what's the data type? It's an int. So it must match number 1 up here. Okay? Now, what about the second call? Here we have two parameters, two arguments rather. The first one, length, is an int. The second one is an int. So that matches number 2 up here. What about this one? The third one. We have two arguments. The first one is an int. The second one is a double, but a double and a float are the same general type. So chances are this will be the function that we call. Recall that if the argument types do not match exactly, an attempt can be made to convert it to the right type. So you can imagine here that height, which is a double, will be demoted to a float. And finally, we have the third one where we have height, which is a double, and base, which is a double, must correspond to this one, to the fourth function that we have there. There are some functions you have been using all along. One is the exit function, which really terminates the program right on the spot. It also passes a value to the operating system. Typically, the value 0 means error-free, and a positive value means there was some error, but the program terminated what we call abnormally. This is the end of this